Hello, my name is Gray Lovelace with Technically Speaking at Source Allies. This year, once again, we are sponsoring Advent of Code. And I know Ben did an awesome video on day 3 or 4 earlier, so I'm going to follow up today with a video on day 7, which was a really fun problem that happened just a few days ago here. You can even see I'm repping my Advent of Code merch. Now, I can't promise that you'll look quite as wonderful as I do, but I do think that you'll look really good if you go check out their store. There's a lot of fun stuff there. I've gotten stuff the last couple of years. But yeah, let's go ahead and dig right into the problem, shall we? So I know I have my code set up here, but let's go back to the source and let's see what this problem looks like. Now, I'm not going to scroll down too far because I've already done this problem and it'll show my answer, and we're going to get to it together. And again, I have done the problem earlier because I am a nerd and stay up late until about 11 o'clock and do these when they drop. But this is really kind of the thought process I had as I was going through this. So we'll rewind back in time a few days and you'll do this with me. Day 7, we had some bridge repair going on. Sounds like there's some engineers. They're trying to repair it. They have a bunch of calibrations that they need to do. But some young elephants were playing nearby and stole all the operators, pachyderms love operators, apparently. So they want to finish, but they can't because of that. So instead, we are going to help them out. It looks like here is our sample input, so I'm going to take that sample input and I'm going to throw it in our sample text. Excellent. And then let's go ahead and grab our input text, which I already have pulled up here, and throw that in there. And let's go back to the problem. So it looks like what's going on is we are evaluating each line from left to right, not according to the precedence of normal operator rules like PEMDAS. And so we only have add and multiply as operators that we can do. And it looks like what we're trying to do is find all of the values that would have total calibration results that equal our numbers here. So basically go through each one of these, find which ones would eventually end up as one of our test numbers on the left-hand side, and then just filter out all the ones that don't. And then at the end, we are going to add up all of the numbers that do have valid results. Cool. Let's dive in. So first thing that I'm seeing, first thing we need to do is we need to go ahead and start running our program. So I have this watching for file changes, so we'll see it update every single time we make a change here and we return something. And I have a little helper class that I've set up that allows me to just define what happens in the parts and define some test cases as well. So our test case here for part 1 is I'm going to take in that sample text that we looked at earlier, which looks like this, and I'm expecting it to equal 0. Instead, let's expect it to equal the correct thing, which is 3749. So let's start there. Awesome. We're still not getting a correct answer. That's expected. And you can see that we are taking in our input as a string and just kind of printing it out here. So first thing I want to do is we're going to process each one of these things as a separate line. So let's go ahead and split it on a new line character, shall we? Excellent. So now you can see that we have an array of all of these different values. And these are really going to turn into their own kind of objects. So every time I have an array of different things and I want them to be transformed into another thing, one for each of the items in that lets me know I need to use a mapping operation. So we're going to go ahead and say map. The input is going to be a line, or this line that we have here, and then we are going to split that line. I don't know what just happened there, but we are going to say line.split, and then we are going to split on the colon that we have, because that will give us the test value as our first record, and then the second record is going to be our all of our remaining numbers that we can use to calculate stuff. Now that we have that done, we could do this all together if we really wanted to, but I like to split it up. I'm going to map again, and this time we have two different things coming in as part of an array. So I could just do that all as one object, or I could do what's called destructuring since we're in TypeScript. And I can just say I have my first number, which is going to be my test value, and I'll just call it test file string because that's what it is right now. And then I also have my other numbers, so I'm going to say nums string. And what I really want to get out of here, to me anyway, I like to use objects a lot. So I'm just going to turn this into a JavaScript object that has some very clear names of what's going on. So we'll call this test val. And really all this is we're going to take the test value that we got out of our split string and we're going to turn it into a number. And that's fairly easy in JavaScript, which is nice. So we'll pass in our test val string that we had before. If we save this, you can see that our object is outputting for us for each one of these values. Looks great. And then if I come over here, I'm going to make our nums array. And so what we want to do here is we want to split on space again, let's say. Actually, let's trim the value first because there's a little bit of space in there that we didn't love before. So we're going to take our nums string. We're going to trim it, which is going to get rid of, oh, not trim right, just trim, please. Thank you. And that's going to get rid of any of the empty space on either side of it since we were left with that. And then we are going to split this guy on a space. Awesome. So that is getting us some numbers here in an array for each one of our values. Now, the only problem here is we're going to need to be able to multiply and add these, so we need to turn them into numbers as well. Again, I have a list or array or collection of values. I want to output something on the other end after transforming them. So we are going to, again, use a map function here. So this is going to be a num string coming in, and then we are going to turn it into a number. Awesome. So that turned it into a number. And really the way JavaScript works, I believe I can just pass in the function we want to send instead, and it'll do it for us. Perfect. That's exactly what we're looking for. So map number will turn everything that's in there that's a string number into a real number for us. So now we have a lot of our data preparation done. This is looking like I want it to be able to start doing some logic on it. So what type of thing do we want to do? It sounds like our end goal is that we want to end up with all of the different lines where a test value is present, which says to me that we are going to end up with a subset of all of the things that we have going into this problem. Anytime I'm going to take a collection of values and I'm going to basically get rid of ones that I don't want, that don't meet a certain criteria, that lets me know that I'm probably going to want to leverage a filter function of some kind. So let's start there. Let's do a filter function, and then we're just going to call this, well, actually, let's do some destructuring again because that's helpful. All right, so because it's an object this time, we're going to destructure in an object notation. And we have our test val that we talked about before, and we have our nums. Excellent. So now that I have this filter function, we need to actually, implement our logic that we're going to filter by. So we need to start taking our numbers and figuring out if they are going to be able to equal our test val. There's a few different options we have here, but the first one I would probably do is do kind of the naive way, which is take all of our numbers and basically build on top of them, doing both a multiplication and an addition operation on each one until I get to the point where I have all of the different possibilities at the end, and then check and see if my test val is in those possibilities. You don't want to pre-optimize too much. We can look at optimizing later maybe, but that's how I would initially approach this. And if for some reason the data set was too big, then I would spend a little bit of time trying to optimize it and be able to get better cycles there. So first, let's go declare some of those operators that we were talking about. So I'm going to need to do an addition operator and a multiplication operator each time. The problem is doing that multiple times. The way I would want to set that up is I would want to have some kind of repeatable list. I could just say do everything in this list multiple times. So let's go ahead and make that. So I'm just going to make a const operators. And this is going to equal an array. And this array is going to have an array of functions in it that we want to be applied to each thing. So every time we're going to get something, we are going to get two values together. And a lot of times if you're using a sorting operator or you're using any kind of like comparison operator, you'll just name those two things A and B. So I'm going to do that here. And those are going to be numbers. Really, instead of defining the function here, let's define the function in our object scope. So our type is going to be an array, and that's going to be an array of a particular set of functions. So our function is going to be coming in A, which is a number, and B, which is also a number. And then we are going to get out of that another number. Pretty simple. And then because we are doing multiples of these, we are going to have an array. Okay. Oh, it does help if you put a comma there instead. And then, awesome. We're looking pretty good. So now that I did that, I shouldn't have to declare quite as many types as I am filling in the list of operators here. So let's say A and B are our inputs. And then if we're doing something as simple as adding, we're just going to return A plus B. Fairly straightforward. And then we are going to do the same thing down here, but instead we are going to multiply. So there's our addition operator and our multiplication operator. And now if we ever do have more operators we need to do things on, we just need to add it to this list and it'll automatically add them for us. All right, so going back to our filter function here, you see we've been failing because I haven't actually filled that in, sorry. So here, if I just say true, we should see everything coming back just like we had before, so we have some data to look at. So we want to go through all of these nums, and we want to basically end up with a new value at the end. So this is the way my brain works a little bit here. I have an array of things or a collection of things, and I want to iterate over them, and I want to end up with a new value at the end based on all of the information that I just iterated through. To me, that lets me know I need to use a reduce function most likely. So a map function will give you one value out per one value kind of sent in. So if I have a collection, I end up with one thing for everything that was in my starting collection. A reduce means I'm going to end up with something completely different over here a lot of the time. So an array in or a collection in, use the information in that collection to produce something new at the other end that is not a one-to-one value. That's what we're looking at here. So let's start with nums, and let's go ahead and call that reduce function, shall we? So reduce takes two parts. It takes a function that's going to be run for every single item in our nums array, and then it also takes, optionally, a starting value. So the thing I really want to start with is the way I'm planning on doing this is starting with the first number in the array because there are no operators done on the as the first one starts. And then for every additional number in the array, we are going to take it and then both multiply it and add to the numbers that already exist in the array and end up with a new larger array with all of the different possibilities. So that lets me know that I probably want to do a starting array with just my first value in our nums. So here's that function that we're going to be making in a second, and then I will start with that second parameter. So that second parameter is going to be an array, and like I said, we're going to start with the very first value from nums. Perfect. Now, one other thing before we get into what the function does, if we're starting with that first value in the array, we actually don't want to process the entire array. We don't want to process the first number again. So we're just going to slice that off before we start processing. So, not splice, slice. Excellent. So that just means it's going to lop off the first number from our array, and then it's going to process the rest of it for us. Sorry, it saved, so it, it sent everything through. So we have all but the first number that we're iterating over every time. And anytime you do a reduce function, you get two, you can optionally have more parameters, but the first parameter is going to be called your accumulator. And so that starts out as this number, this value, the initial value that you give it, and then it also will be whatever you return from your function every single time. So it's accumulating the information that you care about as you go through and reduce all of the values in here. And then the second one is going to be whatever the thing it's iterating on that time is. So we're going to call that num. All right? So down here, or actually a lot of the time what I'll do is I'll call that current, just so I know that that's the current one I'm on. Now, inside this guy, we want to return another list. We want it to return all of the possible values that are available for us. So again, we're getting in our accumulator, which is an array of values. And then for that array of values, we want to produce a new array of values. That says map function to me. So let's say accumulator. And then we are going to say map. And this is going to be our starting value. So I'll just call that an option right now. Or each value in the accumulator is going to be an option because we're slowly building options out. And then for this option, what I want to do is do every single one of the operators that I just showed you before. So we are going to say operators.map, because for every operator, we're getting a new value. And then we're going to apply that operator to both the option that we had and the current value coming into our reducer. So that's going to look like this. Op. And then we were going to say, no, not option, sorry. Yeah, option, and then current. And that should get us some good values. So if I save that, you can see that I'm getting everything back, which is fair because I should be, giving back values here. I'm going to turn this into a map for a second just so you can see what the values look like coming out instead of doing a filter. We'll turn it back to a filter in a moment. So you can see that we have some nested arrays going on, and we don't really want these nested arrays. Those are a little bit gross, to be honest. So instead, what we're going to do is do what's called a flat map. So I talked about a map being that you would get one thing for each of the things going in, but a flat map usually means I'm returning some sort of nested thing. So in this case, we are returning another array when we send in our array, but what we want to do is kind of unwrap that one level and stick it all back into one level of array. So let's try flat mapping instead and see what happens. Awesome. Okay, that looks a little bit better. And you can see we got rid of all of our not a numbers now because we are no longer trying to operate on that array object. We're operating on numbers every single time they come in. Looking pretty good. And really that's all we need to do for that portion of it. I'm going to clean up a little bit because we're not doing any intermittent variables. I'm just going to get rid of that stuff. Let's go ahead and just run a quick format document function. Excellent. Now, what I said we needed to do at the end was we need to test if our options that we've made end up having a test value in them, the value that we were looking at the beginning. So after I've created all of these things, is 3267 one of my options that I ended up with? Should be fairly easy. We have a bunch of numbers here, and then so for those numbers, all I want to do is say dot includes a test val. Excellent. And so if I go back here, turn this back from a map into a filter, you can see that we have a lot fewer values now. So we have a test value of 190, 3267, and 292. And if we go look at Advent of Code again, you can see that those are the three that it calls out that our sample should be able to come back with. Perfect. We're doing some test-driven development over here. So now all I really need to do is take these test values at the end and add them up together. So let's do that. We have all of these nums and test vals as one object right now. So let's go ahead and map and turn each one just into the test val that we want. So we'll take this same code and then we'll just say return test val. Excellent. So now we just have the test values, and then we're just going to sum those all together. Now sum is a helper function I've created, so really we're reducing it by just saying add A to B. But yeah, that gets us our value we're looking for, and then you can see part one, we have a very large number. And if I go check against what my actual submission was, that does look like it was my actual submission. So we did pretty good. Nice work. Let's take a look at part two. So, looking at part two, it looks like they are saying that there's a third type of operator. Okay, cool. We prepared for this. Excellent. It looks like it's a concatenation operator, so it combines the digits from the left and right inputs into a single number. For example, 12, and then the concatenation operator, and then 3, 4, 5 would become 1, 2, 3, 4, 5. Makes sense. All operators are still evaluated left to right, and then really looks like that's everything. We still add everything together at the end for all the results that could happen, and it looks like they were kind and they gave us the answer from the same example that we had above. So let's go ahead and take that answer, go back to our code, and then here I'm going to copy our existing test that we have, but this one's going to be for part two results, and then I'm going to add in that new expected value that we just copied. Okay, cool. So you can see that we passed part one and got the answer. So I'm just going to keep running part one in the background. It's pretty quick. And then for part two, it's trying to evaluate against our sample text, and it's not getting what it's expecting because our part two still just is returning the input string. So sounds like it's going to be extremely similar to what we had before, so great. Let's go check that out. I'm going to copy all of our old stuff, bring it here, hit save. All right, and so as expected, we are getting our old test value back, but we're expecting this new test value back. So all we really need to do is we need to get a new set of operators. So because we're going to be working on a new set of operators, I'm going to take this guy and I'm going to go add it directly back into the function here. We'll consolidate in a second. And then I'm going to come here and make a new set of operators. So this is our operator set right here. And then we're just going to add this new one. So again, we just have an A and a B number coming in. And then we are going to concatenate these two things together, which means I probably want to turn them into a string and then turn them back into a number. So let's say A.toString plus B.toString. And then we're just going to wrap that whole thing in a number. Awesome. Okay, well, I didn't mean for that to go right away, but actually that got us our answer immediately. So all we had to do is just add this one operator because we kind of thought to scale it earlier and make sure that we could add additional operators. Sometimes as you do a lot of these problems, you can tell what direction they might be going for part 2. And this is what I did when I was originally doing this problem on night 7. But you can see that just because we did that operator, now all of a sudden our input processes exactly the way we want it to, our sample passes, and we are able to eventually, after I say run part 2, run part 2. Excellent. So that's our number, and let's go check and see if that was correct. Looking down here, yep, that looks like that's what I submitted, and it was marked correct the first time. So I'm already used a lot of time, so what I'm going to say is I would probably consolidate this. All of the logic is very, very similar, so we would just need to use a certain number of operators. So let's go ahead and do that and clean this up a little bit. I would take this entire part right here, and what we were doing was calibrating. So let's go ahead and name our function calibrate. It's going to take an input string, and then there's one other thing that we're going to need to do here. So remember how I made these a new list of operators inside the function? Let's bring it back out, delete it from here, and we're going to leverage that same operators every time. But the difference is we need to make sure we're either using 2 of the operators or we're using the whole list of operators. So let's take in num of operators to use, and let's just give it a default value of 2, shall we? Okay, so we're calibrating here, and really the only change we would need to make is when we come down here and do this operators map, we might just need to slice it to the number of operators that we have. So operators.slice, and I always get these mixed up. So we're going to start with 0 every time, and then we're going to go to the number of operators to use. So let's see if that works. I don't know if it's going to work off the top of the bat here, but we're going to say calibrate. We're going to come up here, and we're just going to make our part 1 equal calibrate since we have that default function there. Awesome. That worked immediately. So we now have a way where we can pass in the number of operators we want to use. That should make part 2 pretty trivial to do. So let's erase all of part 2. And then we're going to say that we are going to run the calibrate function here. We do have to declare this whole one because we need to pass in our input and then also pass in our new number of operators, which is 3. Also, you might have noticed that I just introduced a big bug. You see how I'm not actually using num of operators here? We should probably leverage that down here where we put the 2 instead of just using the 2 hard-coded. Awesome. And so now that we have put this input 3, we are on our way, and we are leveraging the same function for both parts. And that's how I approached this problem. You can see that the second one is just a little bit long. That's typically a little bit longer than I would like. Sometimes I like to try and get every day running really, really quick. What I would do if we wanted to spend a little bit more time on this is my challenge to you is any time that you are working to try and find if something ends up somewhere. So in this case, our test value. Instead of working from the beginning of the puzzle, finding all possible values and then comparing to your ending. What usually helps, just like when you were a kid and you had the little menus with the maze on them, you start at the end of the puzzle and work your way backwards. And it's going to cut down on the amount of data you have to process dramatically. So what that would look like is I'm going to start with test val, and then for every value backwards in our num array, we're going to slowly either divide or subtract from the test val until we get down and we see if we can match our first number in our num array. And along the way, you know all of your stuff needs to be whole numbers, so you can just get rid of anything that doesn't divide evenly. So if especially if you have a slower computer or something along those lines, that approach would cost significantly less processing power and probably take a lot less time. So yeah, if you guys do that, post below, show us your GitHub repos. We're really excited to see all of the community going out and doing really fun puzzles like this. Thanks for joining me.